Hi, in this video, I'm going to teach you how to solve problems on probabilities involving negative binomial and geometric distributions. Along the way, I will explain how these two distributions are similar and different to binomial distribution. To better understand the two distributions, it is important that we recall what is a binomial distribution. And we will do this by considering one problem that you might have solved before when you were learning the binomial distribution. Suppose you guess in a 10-item multiple choice test with 5 choices. What is the probability that you will get 3 items correct? This is a case of a binomial distribution because it has two possible outcomes. It's either you get the question right or not. Now, the chances of you getting the item correct is 1 out of 5. And the chances or probability that you will not get it right is 5 over or 4 over 5. So we could say that if the probability of success is P, then P is 1 over 5, and the probability of failure, let's say it's a Q, is 4 over 5. Note that for each trial or questions, the chances of you getting it right is not affected by the chances of getting the other questions right. In short, the trials are independent. In addition, it also has a fixed number of trials because you only have to answer 10 multiple choice questions. 10 means there is a fixed number of items. So it's not going to infinity. Now that we are sure that this is a binomial distribution, we could proceed in finding the probability by using the probability formula P of x and combination x, P raised to x, and Q raised to n minus x. In this formula, the n is the number of trials or the number of questions in this multiple choice test, and x is the number of success that we want to achieve in this experiment. That is, we want to get 3 items correct. Note that we already identified the value of P and Q. The P, the probability of success, is 1 over 5, and Q, the probability of failure, and that is not getting the item correct, is 4 out of 5. This over 5 was determined based on the number of choices that we can have. Remember that in order for you to get the answer right in a multiple choice item, there is only one correct answer. So that's 1 out of 5 choices. And you will get the wrong answer 4 out of 5 choices. So the probability that x is equal to 3, the number of successes, is n is 10, x is 3, p is 1 over 5, raised to x, which is 3, and 4 over 5 raised to n minus x, or 10 minus 3, and that is 7. From here, all we have to do is to compute for the value that we can obtain from this expression, and that is equal to 0.2013. So that means the probability of x equals 3 is equal to 20.13%. So with that, let's go now and discuss negative binomial and hypergeometric distributions. Let us take a look at this case. Suppose you answer a multiple choice item again, this time with 20 questions and with 5 choices per item. If you will answer the items in sequence, without skipping, and you answer by guessing what is the probability that you will get 3 items correctly by the 10th question. Now, you should recognize that in the binomial distribution, you were given 10 questions to answer. And from the 10 questions, the goal was to get, or the probability that you will get 3 correct answers. That means when you answer the 10 questions, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, the placement of the 3 correct items can be anywhere in the 10 questions. For instance, your 3 correct answers could be in the second item, in the fourth, and on the ninth. And then there are also other possibilities or cases in which this can happen. That's why we took the combination of 10C3. We can place any of the 3 correct answers, or items rather, from the 10 questions. Now in the new question, what happens is that you only get 10 or 3 questions correctly by the 10th question. So what is the meaning of that statement? If we have 1 to 20 questions, but our concern is that you answer in sequence 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and you still have to continue answering the items, but the goal is by the 10th question, you should have already 3 correct answers. So that means we are forced to consider that the 10th question is correct. So if my goal is to find the probability that you have completed, or you have achieved rather, 3 items correctly, then that means aside from this correct item, you should get 2 from the 9. So therefore, this will be a case of from 9 you should get a 2. And then it should be multiplied by the probability of success, P, and the probability of failure, Q. But we have to know how many times more should we have a success. As we have said, from 9, we need to have 2 successes. So that means P, the probability of success, must be raised into 2. Think of that as if we select, for instance, one particular case that the 2 correct items will happen. Suppose it happened on the 3rd question and on the 5th question, and then the rest are all wrong. In probability, we know that this happened 4 over 5 probability. This also 4 over 5 in probability. This is 1 over 5. This is 4 over 5. 1 over 5. 4 over 5. 4 over 5. 4 over 5. And 4 over 5. So if you have to count all those 1/5, you have 1/5 and 1/5, and that those are our P, then it happened twice. While the Q, which is 4 over 5, happened 1, 2, 3, 4, 5, 6, 7. That means the probability of failure is Q raised to 7. Okay, but don't forget that you still have a success on the 10th question. So all in all, you have times 1 more p. And if you simplify this and input the corresponding probabilities, you have 9 taken 2. That's from 9 blanks, take 2 correct answers. And then p is 1 over 5 raised to, that's a p and 1 more p, that's p squared, and a p, that's 1/5 raised to 3, and then times 4 over 5 raised to 7. Now, if you will recall our first question on the binomial distribution, the answer was 10 taken 3, 1 over 5 raised to 7, raised to 3, times 4 over 5 raised to 7. And you will see, well, I hope that you will able to see that this part of the solution is just the same as the one we obtained from the second problem. The only difference is that the combination is no longer 10 taken 3, but it is 9 taken 2. Okay? But what I want you to see here is how similar the problem were solved. We have a combination of all the possible cases. We have the probability of success P raised to the number of successes, with the probability of failure Q raised to the number of failures. So in general, if we are to answer a negative binomial distribution problem, if we have, so let's take a look at it again. We hope to answer 3 correct items by the 10th question. So 3 correct items by the 10th questions. And our setup became 9 taken 2, 1/5, the p raised to 3, and then 4/5 raised to 7. And we can see, if we just look at the pattern, that this 9 is just 1 less than the 10. This 2 is 1 less than the 3. The p is raised to the number of correct items, and the q, the failure, is raised to the difference of 10 and 3, which is 7. So in general, if our goal is to find the probability that you will get to answer r correct items by a certain x position, then that means we have to take the x position number, that is the 10, became 9, to have x minus 1. And then if we have to get r correct items, this 2 is 1 less than r, so this is r minus 1. And you have the probability raised to r, and not 2, it should be the r3, with the q raised to x minus r. So this is the formula that you can use in finding the probability of a negative binomial distribution. But although there is a formula to solve for it, what I want you to understand is how I was able to get the answer and the solution by just plotting all the possible cases that 3 items will happen. And that is, if we fix the 10th to have a correct answer, that's already one of the 1/5, one of the successes. And you have 9 options left in which you have to take the 2. That is why we had 9 taken 2. But the p should remain p raised to 3 because of the p squared and p, because you have to get 3 items correctly. And then you have q raised to 7 because you have 7 failures in this item or in this set of questions. Now note that I selected 20 items to answer in this problem so that you will understand that some information, even if they are given, should not be used in the problem unless necessary. Since our goal is only to reach the 10th question, the items 11 to 20 has no part in this problem. And that is, we only have to consider up to the 10th question. So this is more like some people will be confused as why is it that we didn't use 20 in the question. The reason is that our concern is only to get 3 items correctly by the 10th question. Okay? Now to support the understanding for the negative binomial, let's have a follow-up question so that you can fully understand what I was able to establish here. Suppose that you still answer the 20 items. This time, what is the probability, or say the goal now is what is the probability that you get 4 questions correctly by the 13th question. With the formula, it is now very easy to answer that. So take note that this will be our x and this will be our r. So the probability that it will happen on the 13th question is 13 minus 1, 12, 4 minus 1, that's r minus 1, 3. Probability of success, still with 5 choices, 1 over 5. Raised to the number of successes in this question, which is 4, because you have to answer 4 questions correctly. And then you have 4 over 5 raised to 13 minus 4, and that is equal to 9. So if we compute for this probability, then this will be 0.0472. So we use up to 4 decimal places. In percent, this is equal to 4.72%. So that's how small the probability is to get 4 questions correctly by the 13th question. That should be our note, by a certain item, by the 13th question. Okay, now finally we go to the last idea, and that is on geometric distribution. Now, geometric distribution is just a special case of a negative binomial distribution. So if you understand how to answer a negative binomial distribution problem, then you should be able to do geometric distribution as well. Now in the geometric distribution, unlike the negative binomial distribution, the geometric distribution focuses on getting the very first success. So let's say you are still answering the 20 multiple choice items, but the goal now is what is the probability that you get the correct answer only by the 10th question. So that means if we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the first 9 questions are wrong, and you only get the correct answer by the 10th question and not in any other item. So even without a formula, although you can use a negative binomial distribution formula, you should be able to see that if the probability of P success is 1/5, because we have 5 choices, and Q is 4/5, that's 4 out of 5, then the probability that you get the correct answer only by the 10th question should be this Q raised to the number of failures, in this case 9, times P, which is the number of success, and there is only 1. And there's only one case in which this can happen, and that you get all the first 9 wrong and the 10th question right, and no other case. So there is no need for us to make or count any other combination, because there is just a single case that this will happen. So the probability itself is already P raised to 1 times Q raised to 9. And if we try to understand it in the context of negative binomial distribution, that is P, that it will happen on the 10th, is you have 10 minus 1, 9, taken R1 question, 1 minus 1 is 0, and then you have P raised to R, which is 1, and then Q raised to X minus R, which is 9. Okay, but again, if you compute the 9 taken 0, you should see that this will be that this is equal to 1. And then you have P raised to 1 and Q raised to 9. Therefore, we have 1 times 1/5 raised to 1 and 4/5 raised to 9. So see, there is only one case in which this can happen. So we can actually disregard the combination part and put the probability of success raised to the number of successes and the probability of failure raised to the number of failures. Okay? So again, for a follow-up, let's try. What is the probability that you get the correct answer only by the 15th question? So one correct answer only by the 15th question. So this should be easy now. The probability that it will happen on the 15th is the probability of success 1/5 raised to 1, and the probability of failure 4/5 raised to 14, because you have only 1 out of 15 correct and 14 incorrect by the 15th question. Okay, so that's how to answer negative binomial distribution and geometric distribution problems. I hope you were able to see how the solutions were similar to that of solving a binomial distribution problem. But make sure to watch out for those statements like by the 10th or whatever place is considered in the problem. But this is our key. If we are to complete a number of successes by a certain number, then that means it's a negative binomial distribution. But if our goal is to get, say, a number of successes 3 out of 10, and that's different to 3 by the 10th. See, the two statements are different. The first one is a binomial distribution. The second one is a negative binomial distribution, because you only get all the successes by the certain number, but in the binomial you will get those 3 out of 10, and they can be anywhere on the 10 questions, like in our example. Okay, so I hope you understand the concepts I presented in this video. You don't need to watch everything again. So if there is something that confuses you, all you have to do is to go to that part and review that portion of the video. Okay, that's it.